me try to do this section in just one video, so I'll jump straight into it. This video covers parallel and perpendicular lines, and this little box that I snagged off of Google does a great job. It basically says that if I have two non-vertical lines, meaning either positive slope, negative slope, or horizontal, two non-different vertical lines are parallel if and only if they have the same slope. So if two lines have the same slope or equal slopes, they're parallel. Similarly, all vertical lines are parallel to each other. So parallel lines have the same slope. If I have two lines and they have the same slope, then the lines are parallel. And vertical lines are parallel. They have undefined slope. I kind of think of undefined as the same. This vertical line would have an undefined slope. That vertical line would have an undefined slope. Technically, undefined isn't an actual number, so maybe we wouldn't say they're the same slope. And that's why they usually make this little call out for vertical lines. So vertical lines have exactly equal slopes. If these two lines are given, the line y equals 1/2 x plus 5 is in slope-intercept form. It has a slope of 1/2. This line, y equals mx 1/2 x plus 1, also has a slope of 1/2. I drew both of them, or this image drew both of them, and both of them had a slope of 1/2. So if you graph them, they become parallel lines, meaning kind of like train tracks, they never meet. Similarly, the lines x equal -2 and x equal 4 are vertical lines, and vertical lines will never meet. The graph of x equal -2 goes through -2 on the x-axis, and it's a vertical line. The graph of x equals to 4 goes through 4 on the x-axis, it's a vertical line. These are parallel lines as well. They're lines that go in the same direction and never meet. So parallel lines have exactly the same, exactly equal slopes. Perpendicular lines, perpendicular means you form a right or 90-degree angle when they cross. Slopes of perpendicular lines are reciprocals with opposite signs. We sometimes say they're negative reciprocals. So parallel lines have equal slopes. Perpendicular lines have slopes that have opposite signs. One has to be positive, the other has to be negative. And on top of slopes being having opposite signs, they have to be reciprocals. So if I gave you two slopes, like if I gave you a line that has a slope of 3/4, the line that's perpendicular to a line that has a slope of 3/4 would have a slope that's the reciprocal with the sign flipped. The reciprocal of 3/4 is 4/3. Flipping the slope isn't enough, you also have to change the sign. So a line that has a slope of 3/4 is going to be perpendicular to a line that has a slope of -4/3. That's what I showed in this picture. These two lines are supposed to meet at a perfectly 90-degree angle. That means they're perpendicular. The two lines that are drawn is y equals 3/4 x plus 5 and y equals -4/3 x minus 6. The line that's drawn in red is the y equals 3/4 x plus 5. It has a slope of 3/4. To graph this line, you'd plot 5 on the y-axis. You'd go up 3 and right 4. The line drawn in blue has a slope of -4/3. To graph this without using a computer program, I'd plot the point -6 on the y-axis. I'd go down 4 and right 3. I'm not going to do that here. This is done for me. And these lines are perpendicular because the slopes are reciprocals with opposite signs. In the world of vertical and horizontal lines, because the undefinedness of the slope, you don't get the sign issue here. Um, Graphs that have vertical and horizontal lines are perpendicular to each other. That's those lines really aren't negative. The slopes really aren't negative reciprocals. If I have a horizontal line, the slope is 0, and a vertical line, the slope is undefined. And these really aren't reciprocals with opposite signs, but all horizontal and vertical lines meet at right angles. So that's kind of a special situation. But lines that have both y's and x's, slanted lines, to be perpendicular, you need slopes that are reciprocals with opposite signs. If you're dealing with verticals and horizontal lines are perpendicular to each other. So now just some simple problems. 35 through 46, I didn't even renumber. This is section 3.2 part B. I just hacked these problems out of section 3.2 part A, and I didn't renumber them. So this would fit perfectly back into section 3.2a, but I just wanted to make it its own section so it would kind of stand alone and not get shuffled, lost in the shuffle. Didn't even take the time to renumber the questions. So each one of these questions has a part A, a part B, and a part C. The first question says find the slope of the given line. In question 36, the equation is written in y equals mx plus b, or slope-intercept form. So the slope of the line that's provided to me is just negative 2/7. It's the number in front of the x. So part A asks me to find the slope of the given line. Part B wants me to find the slopes of all lines that are parallel lines. And all lines parallel to this line will have the same slope, and parallel lines have equal slopes. So any line that's parallel to this line is going to have a slope of negative 7/2, because parallel lines have equal slopes. And that's the answer to part B. Find the slope of all lines that have the slope of any line that's parallel to this line. And part C wants me to find the slope of all lines that are perpendicular to this line. And super easy. If I know the slope of a line, the slope of a perpendicular line I form by taking the reciprocal and changing the sign. So the reciprocal of 2/7 is 7/2, and perpendicular lines, their slopes aren't only reciprocals, they also have opposite signs. We usually say the slopes are negative reciprocals. So the slopes of all perpendicular lines to the given line would be positive 7/2, reciprocal with the sign changed. And that's all there is for 36. 38, basically it is the same question. Part A for 38 wants me to find the slope of the given line, and because 38's in the y equals mx plus b form, it's actually minus b, but that sign doesn't make a matter here. The slope of the given line is 2, because it's written in slope-intercept form. The slope is just the number in front of the x. Part B wants me to find the slope of all lines parallel to the given line. Well, if a line has the same slope, it's going to be parallel. So any line with a slope of 2 is going to be parallel to the given line. And then the trickier part, part C, find the slopes of all lines perpendicular. I need to take the slope that I have and I need to find its reciprocal and switch the sign. So for the perpendicular slope, to find the slopes of lines that are perpendicular to this, I need to find the reciprocal and change the sign. So the given slope is 1/2. The given slope the given slope is 2, which is 2 over 1. The reciprocal of 2 is 1/2. But a perpendicular line, it doesn't only have to have a reciprocal, it has to have the sign changed. So my given line had a slope that was positive, the perpendicular line is going to have a slope that's negative, and I took the reciprocal. (40) asks the same thing. It almost gets silly to do a bunch of these. 40a wants me to find the slope of the given line. Because in 40 the equation is written in y equals mx plus b form, the number in front of the x is the slope of the given line, so the given line has a slope of 7/2. 40b wants me to find the slopes of all lines parallel to this line, and any line that has a slope equal to the given line is going to be parallel. So any line with a slope of 7/5 will be parallel to this line. C wants me to find the slopes of all lines perpendicular to this given line. In order to be perpendicular to a given line, your slope has to have opposite signs and be reciprocal. So I'm going to take the reciprocal of the slope and change its sign. And the slope of any line that's perpendicular is going to be -5/7. 42, same questions. Find the slope of the given line. Find the slopes of all lines that are parallel. Find the slopes of all lines that are perpendicular. In 42, the equation is solved for y. It's in y equals mx plus b form. The number in front of the x is the slope of the given line, so that's going to be my answer to part A. The slope of the given line is -4. For part B, the slope of all parallel lines would be -4 as well, because parallel lines have the same slope. And for part C, to find the slope of all perpendicular lines, I need to find the reciprocal of the slope that I have, and I need to change its sign. So the slope that's given was -4. The reciprocal of -4 is -1/4, because I could write -4 as a fraction with 1 in the denominator, which makes it easier to find the reciprocal. Finding the reciprocal isn't enough to find the slope of the perpendicular line. You also have to change the sign. So I'm going to find the reciprocal, then change the sign to give my slope of my perpendicular line. So the slope of my perpendicular line is going to be 1/4. And then the tricky problems. 44 wants me to know the slope of the given line, the slopes of all parallel lines, and the slopes of all perpendicular lines. 44 has an equation that only has an x, and when an equation only has an x, its slope is undefined. So the slope of the given line, you can spell undefined, is undefined. That means the slope of all parallel lines has to be the same, which is undefined. When I live in the world of undefined slopes, I can't really do negative reciprocals. I just need to know that all vertical and horizontal lines are perpendicular. The line that's given to me, x equal -5, is a vertical line. Goes through -5 on the x-axis. The perpendicular line is going to be horizontal. So the given line has undefined slope, so it's vertical. The perpendicular line needs to be horizontal because vertical and horizontal lines are perpendicular to each other, and horizontal lines have a slope of 0. So to be perpendicular to a vertical line, your slope needs to be 0. So all these problems with x's only or y's only, they're one of these things is not like the other. For 46a, find the slope of the given line. The equation only has a y. Equations that only have y are horizontal lines. They have a slope of 0. So the given line has a slope of 0. Find the slope of all parallel lines. Parallel lines have equal slopes. And for part C, the given line, y equal 1, is horizontal. And lines that are perpendicular to horizontal lines are vertical lines. And vertical lines have undefined slope. So I can't really do the reciprocal of 0. Well, I can, I guess I could, because if the given slope is 0, the reciprocal could be that, and then change the sign. I guess the reciprocal, negative reciprocal, would be that fraction, and that has a 0 in the denominator. It has undefined slope. I'm supposed to just know that when I live in the world of 0 slopes and undefined slopes, that have to think maybe a little outside the box. If I'm given a horizontal line, then it has a slope of 0. Vertical lines are perpendicular, and those have a slope that are undefined. A few more problems. We should be able to do this in one push. So problems 47 through 52 give the description of 2 lines. Actually, they give points on 2 lines. We're asked to find the slope of the line that passes through the first 2 points, find the slope of the line that passes through the second 2 points, and figure out if the lines are parallel, perpendicular, or not parallel and not perpendicular. It's not particularly hard. Let me just do this. So question 48 wants me to find the slope of the first line. Line 1 is what I need to find the slope of first. To find the slope of the first line mentioned in problem 48, I'll take the y-coordinate of the second point minus the y-coordinate of the first point, put that in the numerator of the fraction, used to calculate the slope, and then in the denominator, x-coordinate of the second point minus x-coordinate of the first point. So line 1 in problem 48 has a slope of 11 over 6. I'll do the same for line 2. Couldn't even spell slope there. Moron. So for my slope of line 2, I'm going to take y-coordinate of the second point, which is 2, minus y-coordinate of the first point, which is 8, divided by x-coordinate of the second point, which is 17, minus x-coordinate of the first point. Numerator comes out to -6. The denominator comes out to positive 11. So line 2 is going to have a slope of -6 over 11. This is asked for. It says find the slope of line 1. Line 1 has a slope of 11 over 6. Find the slope of line 2. Line 2 has a slope of -6 over 11. And then are the lines parallel, perpendicular, or neither? Well, if I look at the slopes are reciprocals. One's positive and the other is negative. These lines, as I go off the screen, these lines are perpendicular. because their slopes are reciprocals with opposite signs. And that's everything for problem 48. We have 2 more of these, and then we'll be done with this part of the video. So same deal for problem 50. Find the slope of line 1, find the slope of line 2, figure out if they're parallel, perpendicular, or neither. So I'm going to start off doing the slope of line 1. I'm going to write m for slope, and then I'm going to do y-coordinate of the second point, -8, minus y-coordinate of the first point, -2, over x-coordinate of the second point, 3, minus x-coordinate of the first point, 4. The numerator has a double negative that I can make positive. The denominator, I can do 3 minus 4 in my head. So this slope comes out to be -6 over -1, which is just 6. So the slope of the first line is 6. That's one of the 3 answers that I need to give. Now I'm going to do the slope of the second line because that's the second thing I'm asked to do. The slope of the second line, I'll do y-coordinate of the second point, 24, minus y-coordinate of the first point, 6, divided by x-coordinate of the second point, 9, minus x-coordinate of the first point, 6. This is going to give me 18 over 3, which is 6. So my second answer, slope of my second line, is going to be m equal to 6. Done with the second of the third questions. Now, are the lines parallel, perpendicular, or neither? Slopes are exactly the same, so these lines are parallel. One more, and we'll be done with this part of the video. Nice 25 minutes, that's a reasonable amount of time. Same question for 52. So for 52, line 1, its slope is going to be calculated by forming a fraction. In the numerator, y-coordinate of the second point, 5, minus y-coordinate of the first point, -14. In the denominator of that fraction, x-coordinate of the first point, -2, minus x-coordinate of the second point, 7. First line, as I go to calculate the slope, the numerator had a double negative that I'll make positive. The denominator I can simplify in my head. -2 minus 7 is -9. My calculator's in another room right now, otherwise I would just do this on my calculator. My algebra for the slope of line 1 gives me the fraction 19 over -1, 19 over -9. I'm going to write that with the negative in the numerator. And now I'll work on line 2. Its slope is going to be calculated by doing 24 minus 5 over 9 minus 0. 24 over 5 is positive 19. 9 minus 0 is 9. So my slope of line 2 is positive 19 over 9. And then I need to say, are these lines parallel, perpendicular, or neither? They're not parallel because their slopes aren't exactly the same, and they're not perpendicular because the slopes aren't reciprocals. To be perpendicular, it's not enough just to have different signs, you have to also be reciprocals, so these are neither. These are not parallel, nor are they perpendicular. That would be my third and final answer. All right, so that should be the end of this. We still have a part C to this section. It doesn't end just yet.